Hey everyone, and welcome. Today, we are diving headfirst into the absolutely dazzling world of figure skating. You know, it's that incredible sport where pure artistry meets some seriously mind-bending physics. It's where athletes are constantly pushing the limits of what we think is humanly possible, all on a razor-thin blade of steel. And right at the heart of it all, there's one jump that has defined greatness for more than 100 years.
So yeah, at the center of pretty much every competition is this one legendary challenge. The sources we're looking at call it the sport's oldest and most difficult jump, the axel. So what is it about this jump that makes it the ultimate test for any skater?
Well, to answer that, we really have to talk about this guy, Ilia Malinin. His nickname is the Quad God, and for good reason. He's the American skater who went out and did something that a lot of people thought was literally impossible. Back in 2022, he became the first, and as of now, the only person to ever land a clean quadruple axel in competition.
So that's our big question for today. How in the world did he do it? To really get a handle on this incredible feat, we first have to crack the basic code of all figure skating jumps. You know, we got to learn the alphabet before we can read the epic poetry.
Okay, so let's start with the absolute fundamentals. Every single jump you see in figure skating, no matter how ridiculously complex it looks, starts in one of only two ways. It really all comes down to how the skater leaves the ice.
On the ice, everything boils down to these two types of takeoffs. First, you have your edge jumps. This is where a skater launches smoothly from either the inside or the outside edge of their blade. Just think of a really fluid, gliding motion. And then you've got your toe pick jumps. This is where the skater uses those jagged teeth right at the front of the blade to dig into the ice and just powerfully vault themselves into the air. So one is all about flow, and the other is all about force.
Okay, so keeping those two takeoffs in mind, we can now actually identify all 6 of the officially recognized jumps in competitive figure skating. Each one is just a unique combination of using an edge or a toe pick, and of course, rotation.
Think of this table as your ultimate spotter's guide. The jumps are all listed here in order of their general difficulty, starting with the toe loop and going all the way up to the axle. And you can see the key details. The Salchow, for example, has this big, sweeping, natural takeoff. The loop is pretty cool because you take off and land on the exact same foot. But then look at the bottom, the axle. It's an edge jump, sure, but it is the only one with a forward takeoff. Now, why does that one little detail change absolutely everything?
And hey, here's a little pro tip for the next time you're watching a competition. You'll probably hear the commentators talking about the Lutz, which is a tricky counter-rotational jump. A really common mistake is something called a flutz. That's when a skater accidentally switches to the wrong edge right before they take off. It's a super subtle mistake, but believe me, it is a huge deal for the judges. All right, so we've got the jumps covered, but to really truly understand the axle, and especially a quad axel, we need to talk about another key element of skating. It's a part where they seem to just defy the laws of physics, the science of the spin.
Come on, we've all seen this. A skater starts a spin, they're going at a pretty steady pace, and then, bam! Without any visible push, they suddenly accelerate into this incredible blur. How is that even possible? I mean, where does all that extra speed come from?
The answer isn't magic, it's pure physics. And the key principle here is the law of conservation of angular momentum. Now, in simple terms, what this means is that for anything that's spinning, like a figure skater, the total amount of spin energy has to stay the same unless some outside force messes with it. A skater can't just add more spin in the middle of a jump, but what they can do is change how that spin is distributed through their body.
And this shows you exactly how it works. You can think of angular momentum as your mass distribution multiplied by your rotational speed. So if the total has to stay the same, it becomes a trade-off. When a skater has their arms and legs stretched out, their mass is far from their center. To keep the equation balanced, their speed has to go down. But when they pull their arms and legs in super tight, their mass gets way closer to the center, so their speed has to increase to compensate. This exact principle is what lets them crank out multiple rotations in midair. And you see this principle literally everywhere. Not just on the ice. It's why you speed up in a swivel chair when you pull your legs in. It's how a high diver controls their flips by going into a tight tuck position. It's even why planets actually move faster in their orbits when they get closer to the sun. It is all the exact same fundamental rule of the universe.
Okay, so now we have all the pieces of the puzzle. We get the unique forward takeoff of the axle, and we understand the physics of angular momentum. So let's put it all together and finally reveal the secret behind Ilia Malinin's historic,
unbelievable jump.
So here it is. This is the anatomy of the impossible. First, remember that forward takeoff? That means a quad axel is actually 4.5 rotations, so he needs just explosive power to get enough hang time. Then, he has to pull his body into the tightest possible position to spin fast enough. That's our angular momentum right there in action. All 4.5 of those spins happen in less than 1 second. And then, finally, he has to land and absorb a force that can be up to 10 times his own body weight. It's just an incredible combination of power, timing, and physics.
Malinin's achievement wasn't just a personal win for him. It was really the peak of a mountain that skaters have been trying to climb for the entire history of the sport.
Just look at the sheer amount of time we're talking about here. It took a staggering 66 years to get from the first single axel to the first double, then another 30 years before a skater finally nailed the triple. And after that, a 44-year wait before Ilia Malinin finally conquered the quad. This timeline just perfectly illustrates how monumental the challenge really is. Every single rotation they add represents a whole new barrier of human performance that took decades of innovation and pure athleticism to break through.
Which, of course, brings us to our final question. With the quad axel now a reality, what's next? Will we one day see a quintuple jump? What physical barriers are still out there left to be broken? As athletes like Ilia Malinin have shown us, the impossible in figure skating is only impossible until someone comes along and does it. And that, right there, is what makes the sport so incredible to watch.